lots and lots of people are setting up video cameras in their home. It could be webcams. It could be iPods that have been retrofitted to be security cameras. It could be baby monitors. So all of these different technologies have emerged to monitor home spaces, retail spaces, and so on. And that creates a lot of data. And what are we going to do with it? So Andy will be moderating this panel, and he will introduce the panelists. So thank you.
Hello. Thanks, Serge. I'm going to invite the panelists up here with me to introduce themselves. This should be pretty interesting. I'm going to change the topic just ever so slightly, which we'll get into when we talk about this. I think a lot of video intelligence is going to end up being about decision-making, of which security is a piece, a component. But there are many more aspects that we're going to get into. So Carter, I'm going to start with an introduction.
Sure. My name's Carter. I'm co-founder and CEO of Camio, and we do smart video monitoring that's accessible and easy for everybody. So that's a quick one-line summary on what Camio does.
Hi, I'm Samir Kumar. I look after product and business development in Qualcomm research, and specifically our efforts in computer vision and machine learning.
Good. I'm going to ask you guys to be much more long-winded than that because there are only two of you, and this is not a subject of deep knowledge for me. But so I'd like to organize things as sort of in three parts, roughly. I'll keep an eye on the clock, and I hope this inspires a few questions from the audience because it's a fascinating topic. But first, I'd like to talk about state of the art, kind of where we are in your respective companies and what you're working on now. Then, of course, dive a little bit into security with the obvious privacy topic being one when we talk about security and video and ubiquity of cameras. And then I'd like to spend the majority of the time on what's coming in the future and how optimistic or pessimistic we are about what's happening. So Samir, can you say a few words about, more than a few words actually, about what you're working on and what Qualcomm is up to?
Sure. So you may or may not have heard of something called Qualcomm Zeroth, which is our effort to create a platform on which you can run deep neural networks on embedded systems, specifically Snapdragon-powered systems, and being able to do applications like on-device classification. So you've seen examples throughout the day of image tagging or being able to classify videos. Now imagine being able to do that fully on device on an embedded system without requiring a cloud connection. So we've demonstrated some of this already with doing, for example, in camera preview, being able to do concept detection. So you're looking at buildings or cars or planes or bicycles or things like that. And really taking state-of-the-art convolutional neural nets and showing that you can, in fact, run these on existing mobile and embedded devices with the power constraints or the thermal constraints that they have and get really good performance. And that's really the focus of our research effort is how do you do this on an embedded platform? How do you make it go fast without destroying the user experience or killing the battery of the device? And then creating a platform on which you can deliver lots of use cases using a common kind of runtime on platform on which people can build different types of machine learning classifiers and specifically deep neural nets. And then you could do it for audio, you can do it for video, you can do it for imaging, you can do sensor fusion, and things like that.
Carter?
Sure. Well, just as background, when we started Camio, it had kind of harkened back to memories. Luke Vincent is here, Director of Street View Engineering. When we launched that at Google, one of the things that people did right away when they were first exposed to Street View in every usability lab was they'd go to their house. And that's not surprising. But the shocking part was that at least one person in every usability study would say right after that, wait a minute, why isn't my car parked there? I left it there this morning. And all the engineers laugh at this, but it got us thinking like, well, why isn't the real world indexable and searchable in real time? And what would it take to make that happen? And so a lot of the innovation that we're focused on is doing it at a scale and price that's accessible to everybody. So like traditional computer vision has a lot of brute force computation and stuff that is expensive. And so how do you do that across millions of cameras where you're processing in real time and labeling in real time so that I get an alert on my phone that just says, oh, UPS has a large package on my doorstep at 2:32. And so the innovation that we were focused on was blending the image analysis part with the machine learning part so that every single camera has its own set of neural nets actually that are learning what's interesting in that scene and approaching the problem differently in the sense that a little gray furry animal on my walkway that's a squirrel is not particularly interesting, but to my co-founder who has a place in Tahoe, that's a coyote in his backyard in the same dimension, same kind of object that you would see. And so learning, even without knowing whether it's a coyote or a squirrel, that the squirrel is uninteresting to me, not because we know it's a squirrel, but just because we know that pattern for that camera and that user is uninteresting. Whereas the coyote, also not known to be a coyote, but is very interesting because he saves it or shares it, or we have a little thumbs up, thumbs down, kind of like a Pandora music rating. And that just learns over time quickly so that we can train a camera within the first like 30 ratings so that you really get a clean signal so you can see a digest of a day on one screen. So a lot of the work that we're doing in terms of current computer science is just doing things cheaply. And so we'd love for more capable devices to come out. Our app-based stuff tries to push as much as to the edge as possible, but we also want to have a uniformity and accessibility so that it's open to any camera source. So we're kind of in this zone where we'd love to have more capable clients, but they're not evenly accessible. And so that whole shift on what's in the cloud and what's on the edge and the client, I hope just becomes a really nice collaboration to kind of take things to the next level in learning.
Cool. That was the almost perfect segue into my next question, actually. Okay. So it's almost like we rehearsed this. We did have a short phone call, but so around the topic of what logic resides in the cloud versus what can be on device, and think a little into the future where some more of Qualcomm innovation will appear on phones. If I can take the liberty of situating you guys on either side of the debate, if it even is a debate, or Carter, what you guys are doing at Camio is much more, for the time being, cloud-based, cloud intelligence. Lots of cheap virtual machines doing a lot of interesting logic at a low cost. And Samir, you guys, spending a lot of money on research to get more of that onto our phones, with the obvious sort of subtext of what does that mean for security implications. The more intelligence I can get for monitoring my home at the cost of having more of it in the cloud and accessible to prying eyes. So I'm talking in extremes just to sort of set up a little debate here. But the question, I guess, is over time, what are the right kinds of cognitive capabilities to reside in the cloud, and what are the right ones to be in my pocket?
Yeah, that's a good question. So I think I would break it up into two pieces. So I think there's clearly evidence that you can take trained classifiers, that let's say you train them in the cloud with lots and lots of data, and they're able to detect things like cats, or that's like a mountain goat, or whatever kind of thing that you're looking for, and bringing that trained classifier and then running that at the edge or on device, and therefore being able to extract that intelligence or salient information immediately, and then make smart decisions about what aspect of that do you want to send to the cloud for more processing. So I think blindly sending everything to the cloud without first doing some, let's say, filtering or edge processing, I think hopefully everyone agrees that over time, as we're able to do more and more classification on device, it's clear that it's a hybrid model. Now, the other piece of this is, in the long term, the whole bit about having to train models and having to have all of the data in the cloud, does that also have to be true? One area that we get excited about that we hope to see realized, let's say in the next, 5 to 10 years, is this notion of distributed learning. So I've got, billions of Snapdragon-powered devices out there. They're not going to have the capability of a GPU cluster in the cloud to train models. But now I've got billions of these, and people are contributing both training data and, let's say, a little bit of compute to also collectively build models. And then ultimately decide which part of that model makes sense to have on their device versus, your device or somebody else's device. I think that's where we would love to see the world go to. But there's a lot more R&D that needs to be done to make distributed learning, including on mobile hardware, viable and commercially viable. But the vision is there, and there's definitely evidence that some elements of that are in fact possible and are worth investing in.
Yeah, already today, just as an example, one of the biggest problems with video monitoring is all the false alerts. And if you point a camera like your old Android phone out the window, just shimmering leaves are changing shadows, or the lights coming over will trigger a lot of false alerts. So as an example, Camio on the cloud will develop an adaptive motion filter that says, oh, it must be breezy for the next 2 minutes because it started seeing a lot of activity in a particular region. So ignore that as significant motion for the next N number of minutes. And that's something that we can push to the client saying, hey, the cloud has learned that this is not interesting, so apply this mask locally and don't send everything to the cloud. So that's like a simple version. But then some of the learnings, so for example, rain night streaks on infrared cameras. The cloud is uniquely good at being able to see that it's raining across a region, and so it gives you a little more confidence to say that's unlikely to be something interesting. It's probably just among the pattern of rain. So I think this hybrid thing is key. Even as we get great edge capabilities, you'll still want to have the supplement and the ease of interaction across different guests that are accessing the video. Like our cameras are trained by everybody that's a guest on the account, so that you can increase the density of feedback. So the things that people play or share can be known to be good, and the things that people downvote or delete are known to be bad. So that kind of ease in having coordination across people is always cloud. And the part that I dispute about your prying eyes comment on the cloud is that I think that delineation and security there's the machine learning and capability part, but the security part, I feel much better having it in the cloud. You look at what happened with the FTC, I think, fined a whole bunch of camera makers for having 50,000 cameras accessible, because every single, even major vendors of security cameras and Comcast and ADT and all these, they'll say step one is enable plug-and-play port forwarding, so you can see remotely live. And then no one puts passwords on their devices, the firmware is hackable, and you end up with more risk than I think having just a secure connection with encrypted storage, distributed data center. So I think the natural kind of emotional reaction around, wait, my stuff is in the cloud, I feel like is maybe going to change if people really dissect the elements of the security, because I think I feel safer with two-factor authentication encrypted on the disk. And so anyway, that was a side point on the cloud versus.
Yeah, no, that's good.
Yeah.
You can't dispute it because it's not actually my opinion. I'm just trying, trying to stir up some controversy where there is none. You guys are both agreeable folks working on amazing stuff, so there may not be any controversy. Well, we'll talk about security in a minute.
Yeah.
So again, mostly from a layperson's perspective, to do the kinds of things that we're talking about, cognitive analysis. You talked a little bit, Carter, about how to filter out noise, whether it's rain or leaves. Given the amount of video that people are generating and the amount exponentially that we expect it to increase as tools like what you're developing become more commoditized, more available, and more generally used, what's coming next, or what do you need to think about in terms of storage, just things that explode very quickly, like storage, like noise, uninteresting frames in video? How do you think about that?
I mean, the first thing that we're asking camera makers, we can control the part when we are running the iOS or Android app or web browser app, but for a camera maker, we're saying, can you please send downsampled stuff to the cloud for analysis while keeping the high-res local, as an example, because that way you could get enough known immediately. Like if within 10 seconds you know whether an event is interesting, then you can queue the request for the high-res stuff and leave it on device otherwise. And so I think some very simple first steps will easily handle our bandwidth and kind of amount of video problems just with that level of tiering, apart from any improvements we have in connectivity and bandwidth speeds. But just that basic stuff, like most of the image analysis you can do on 120 pixel images. In fact, sometimes it's better because the noise is less when you have a lower res image, and so you could potentially have just a trickle of data and still get a lot of the information content out, only to have the high res stuff subsequently fetched when you really want to see the full HD.
Yeah, so I fully agree with what was just said. I think the other thing I would add is, in order for us to be able to deal with the explosion in the amount of video that's being collected, and it's not just going to be like true security cameras. There's cameras in cars, there's cameras in drones, there's wearable cameras. How do you decide what's interesting and what's not? And so generally for us to get better at doing, let's say, anomaly detection, because those are the things that I didn't know about or I did not predict, and I do want to capture that. Versus right now, it's all about, well, we want to detect things like, people shaking hands or hugging or, my dog jumping through the door or something like that. So I predefine what these are. I can train on that and create a classifier and then look for those events. But when I think about security, what's actually the most interesting is when there's an anomaly. And how do you define an anomaly? How do you train to detect an anomaly? I think that's a very interesting area, and there's a lot more research that needs to happen there. And I think, as we talked about in the call, this notion of, and you're seeing this in deep learning, that going to unsupervised learning. You don't have labels for the data. You just have a lot of data, and you're able to look for patterns that are relative differences, and then decide, okay, well, these are the ones that are interesting, and I need to look at these further. I think getting to a place where unsupervised learning advances far enough that it becomes commercially viable, that will be another big breakthrough in doing, really robust anomaly detection.
Great. Another awesome segue. Did you want
Yeah,
to
well,
say one more
and
thing?
just that's one of the most popular features is we have a Camio daily that just highlights the top 4 events of the day, and it tries to find the unusual stuff, but it's both successful and failure because the highest ranking events sometimes have the people that were already there in the event, and so we want that's another example of cloud influencing the ranking, where if you're at the same network location as the camera, it's unlikely that you think that was. So there's a whole bunch of signals you can use based on where the user is, where the family is, or the coworkers are, and ranking anomalies like longitudinally across an extended period of time. Like, what is the weekly pattern? What's the daily pattern? So there's a lot there, but there's high demand for it, is what I was leading with, is that people love seeing the highlight of anomalies every day. That's like a top feature. It's like 60% open rate and 52% subsequent search rate just on this one daily email.
So let's jump into sort of security and society a little bit. That was a good segue because anomaly detection, obviously, one essential aspect of security in general, and maintaining safety and just some of the things that society is supposed to guarantee us that can be enabled, but also there's the darker side of security and surveillance. So I want to raise the Boston Marathon bombing because it's so close in time proximity. The events of last week, I think, have it burned in everybody's mind right now. Taking a positive spin on that, what could be different were that, God forbid, to happen in the future or not happen? And talk about how it might be prevented, but more clearly, more succinctly, how your technologies and the combination of cloud analysis and onboard cognitive intelligence on phones could have been applied.
That was a galvanizing thing for us when that happened, because even if only 1 out of 10 residences in Watertown had something like the video monitoring, then the kind of collaboration that could have avoided people getting killed with the pursuit of those guys, I think, is so powerful, because you could say something. One of the things that I love is the idea of private convenience and public benefit, where the private convenience is you get to see your package delivered, your kids are home, is my mom okay? Those kinds of things that are just private to you, no one else can see it. But then if something happens where there's a public safety issue, private citizens can marshal a coordinated response instantly, which is just, I think, so powerful. In fact, there was a tech reporter for the local San Francisco Cron News that did a segment on Camio, and afterwards he said, I think it's people's civic duty to have a camera facing the front. And I was like, that's like a pretty strong statement because it's controversial and stuff, but I get where he's coming from, because you could have police broadcast saying, hey, we're looking for a person in a black hat and a white shirt, that last seen at 2 p.m. And you could quickly all the limitations that were mentioned around computer vision are so painful, but humans can glance at a thing so quickly to identify. So one of the things that Camio is doing is enabling a broadcast like that to just say, hey, you have 3 candidate matches for a recent request. Would you be willing to participate? And then you just browse and say yes, no, maybe. And like being able to instantly marshal that kind of coordinated response, I think is awesome, even while balancing, there's no kind of big brother surveillance eye that sees across all cameras. It's predicated on the opt-in support from people. So I love that as a model, and it was specifically in response to what everybody saw, how effective video was in the Boston bombing. So.
Yeah, so the Boston bombing one is really interesting because maybe some people have seen it, but Frontline actually did a special that talked about all of the technology that was used to find the Boston bombers. And they highlighted a couple of things that are very relevant to this discussion. One was, what is the current state of the art in facial recognition technology that the FBI and different law enforcement agencies in the US are using? And then the second piece that they highlighted is the fact that they have so many different cameras in so many different locations, and getting a centralized feed where they have analysts that are looking for anomalies. I mean, today it's a manual process. One of the key ones was just over and over looking at one particular corner in Boston and seeing one of the bombers drop a bag at the next to the, some mailbox or something in the street. Now imagine if we could actually automate that process. So if I were to build a engine that said, I'm looking for this type of anomaly. If someone drops a physical object or a bag in this location, I want the camera to actually trigger an alert or automatically do that versus a human being. So that's one example. The other piece that they highlighted is when you look at face recognition, even with state of the art, there are still many challenges in getting it to work. Dealing with occlusion, for example. I got a really grainy partial shot of a face, and the FBI is doing some interesting things like basically generating or creating a face model just with partial information and then trying to do matching on that. But if you think again about machine learning, there's clearly more opportunities to advance facial recognition, doing things like generative models, where a neural network could hallucinate what a face looks like and not necessarily have a bunch of labeled examples of this is the face that you're looking for. So that's another example. The last piece was the crowdsourcing piece, which is what I think you're also talking about. Everyone, whether it's on Facebook or different social networks, contributing their photos and then aiding, the law enforcement agencies to find these anomalies. Again, being able to do some of that automatically, where you can use my camera, you can use my device, and I can do some interesting things on device and then send that up centrally to law enforcement or to a cloud. And I've already done some first-level filtering, first-level processing. And then, the experts can look for the more detailed information to make a decision if it's interesting or not. An analogy I like to think about is SETI at home, right? So SETI's out collecting tons and tons of data from different radio telescopes. You can contribute your computer to process some of that and then send that back to the folks at SETI, and then they'll decide, okay, well, this data is interesting, maybe there's a signal here. Now imagine doing that for computer vision with all of the phone cameras or all the wearable cameras or car cameras that we'll have, and applying that same model.
Cool. So jumping into kind of the future, two big questions, same order of magnitude of what we've been talking about. I'm going to ask the first one and then open it up to the audience for a few questions and then follow up with the final one. So it seems like a fair assumption based on the discussion we just had is that connecting everybody's camera, security side and cloud being as secure as it could possibly be, is something that will enable some of the innovations, home security, larger scale national security, state security, cities. But it's a huge task. I mean, I don't know what protocols exist or what standards exist that would even enable connecting everything. But how do you guys think about approaching that problem? Imagine that you two are at the forefront of making that happen in the next decade.
Well, I mean, there's the simple version, which actually has happened already in my neighborhood. We had a robbery that was rare, but the guy had $35,000 of cash in the back of his car because he owned a bar in San Francisco and would do check cashing on a certain time of the month. So there were 3 people that were casing him, and they carjacked and robbed him. And it was as if a director had said, cut to cam 1, cut to cam 2, cut to cam 3, because they robbed a street where the Camio co-founder lived, so all of the neighbors had Camio. And so it was a social experiment, because within 5 minutes of the robbery, every neighbor had donated their 5-minute window. I remember 4:41 to 4:45. And with the single click, they just donate, and now the police have 7 neighbors with links to that specific time, facing the street, showing scene by scene the 3 people that did the robbery. So it's not even that. It's not future, actually. You can do this.
So your answer is that everyone should subscribe to Camio.
Well, no. That's so the protocol is you should be able to have a link, and the link should link to something that people can use. So yes, Camio produces URLs, and they can go to vetted video clips that are distilled just to the parts that are relevant. So I think the standards are there in the sense that it's going to be human collaboration, because there's no machine good enough to prosecute a crime or investigate a crime. So it really comes down to using the standards we have for already great information exchange and collaboration, and just not having it all locked up in DVRs and things that you can't access. So I would just say web links is the standard.
Samir, anything that we should be thinking about on phones or beyond?
I think, again, this comes back to a little bit about, as much as there's the social good aspect of sharing your camera data, there's also the privacy paranoia. So the question is, how do you balance those things? And I don't know if there's a perfect answer to that, but one place to look at is when you think about things like peer-to-peer networks and headless type of deployment. So things we've seen with BitTorrent, and BitTorrent, as many of you know, recently is launched a messaging service where I don't need to have like a cloud backend to do IP messaging. I can really go just peer-to-peer. Well, what if I could do that with cameras? What if I could just say, I want to share my camera feed with my neighborhood as a starting point? Maybe it's 5, 10, 15 people. Maybe there's a second element to that, is then when we collectively decide elements of that we want to share with the cloud or with the authorities, we would also enable that. But a starting point would be maybe not immediately jumping into my camera, and my camera information is immediately going to law enforcement or to the authorities or to the cloud, but I feel comfortable sharing it with my neighbors and participating in this web, this local web, for finding anomalies or finding threats in my area.
Great. Any questions from the audience before we wrap up? There's one over there. Run, Evan, run.
They identified them, but did not apprehend them. They were in Hunter's Point, and the Burlingame police said that they knew who they were. They came and deposed me for admissibility of evidence and things. And frankly, I don't think they even apprehended the guys, even after knowing who they were. So I don't understand, and I've pinged the police because I wanted to actually close the loop on that story. And I still have to do the follow-up to see whatever happened. They said they had ID'd both the car, but there were so many embarrassing things. The car they hijacked was left parked in a neighbor's driveway, and the neighbor was calling the police saying, hey, there's a car parked here that shouldn't. And they were saying, that's a private matter, sir. You need to hire your own towing company. And they had the license plate on file. So there were just a series of embarrassing kind of prosecution side that I just need to close the loop to see what happened. But it wasn't favorable light.
The mic's not on or not working. You can just shout. I bet we can hear you.
It's for the video, we want to have it on. So the question is concerning CCTV. So we all know England has the highest saturation of CCTV. I know Times Square as a location has the highest saturation of cameras in the world, I think I've read recently. But recently also The Guardian really did an article on CCTV concerning that it does not prevent, like street crime has not decreased in England as a result of CCTV, and also prosecution of criminals hasn't increased as a direct result of CCTV. The only thing that does CCTV help with is with planned crimes, right? Like jewelry store, etc. So to your point, that saying that civic duty of everybody to have a camera, isn't that just kind of absurd? How is it my civic duty? Like the government already has cameras everywhere, and it doesn't help anyways.
Andy, can you repeat the question?
I can try. So, I mean, to summarize, the question is, given the density of CCTV cameras, stationary cameras in cities, there's a sense that there may be plenty of cameras. Why is it our civic duty to provide more?
Well, so I know the study you're referencing, and I think the counter argument is that it's not the severity of punishment or anything that matters, it's the certainty of being caught. And so, like, we live in this kind of fear state, like, oh, we got to lock doors, have guns, and so to me, cameras are an alternative where there's more good people than bad. If bad actors can't outrun the perimeter of people that are somehow going to contribute to the certainty of their being caught, then that's the civic duty part. It's like, well, you don't have to share it at all. It's all private to you. But if something bad happens and there's a collective deterrent just by knowing that there's a certainty of being caught as a bad actor, even though no one can see that, like the part of the problem with central government monitoring is nobody's looking at it. It's like black box recordings that are ex post facto forensic evidence, as opposed to like a door-to-door solicitor that is casing a neighborhood and the neighbors say, hey, this guy tried my door without ringing the doorbell. Immediately the police are there at the time that the person is planning the burglary. So I don't think it's apples to apples comparison with like a state-sponsored central CCTV system versus a distributed network of private citizens that are just trying to say, let's relax, knowing there's more good people than bad, and we can coordinate if anything does happen that's bad.
Two more questions right over here.
Yeah, let's take one more, and then I want to make sure. Yeah.
Okay, one more question.
So I don't know if you guys heard recently, BAE Systems said they're going to build an automated drone that could go bomb on its own. In that case, who bears the responsibility? Is it us, because we're developing technology that can recognize things and while it's flying, and it's like, oh, this is a terrorist, and it just goes bomb something? Who's really responsible there? And should we even be building these things?
So let's make it even more personal versus a drone that, let's say, goes and bombs. Let's think about self-driving cars. And let's say they're using computer vision to run autopilot and also then make decisions about, okay, do I stop? Do I turn left? Do I turn right? I see a pedestrian. I don't want to hit them. I want to hit the wall. Even more controversial, you may have heard of this scenario. I've got a self-driving car. An accident is going to happen no matter what you do. There's no way to stop it. You can either hit those 4 children crossing the street or drive it into the wall and kill all the passengers in the car. What's the kind of the moral dilemma? Like, if whatever the car does, it's going to cause the loss of human life. So what should it do in that particular example? I think these are all very good questions, whether it's for the drone use case and it's a military application, but the one that we're all going to be facing very, very soon is these robots, these autonomous vehicles or semi-autonomous vehicles that are going to be making decisions on our behalf. And in some cases, those could be decisions that have an impact on human life. But I don't know if there's a good answer, a good, clear answer on that. And there is a lot of legal debate happening on, well, let's take cars again. Where's the liability? Is it with the driver? Is it with the manufacturer? What is the insurance policy going to look like in that type of situation? Very, very active, open discussions, but I don't think there's a clear defining answer there.
Okay, we're just about out of time. I just want to ask you guys one quick one. Given we have an audience of entrepreneurs and scientists and engineers, what's the number one innovation you think we need to see in the next few years to move the ball forward?
I think there's more than one.
Your top one or two?
Well, I'm going to give you 2 answers anyways. The first one is, if you want to do this out in the real world and in lots and lots of, whether it's your wearable camera or a drone or a car or your mobile phones, how do you do always on at very low power and run sophisticated machine learning algorithms? We're seeing lots of noise about, well, we can do these kinds of hardware accelerators to do this really fast or at very low power. But the big white elephant in the room is right now, the way we're architected things, the biggest bottleneck is memory, moving things in and out of memory, the cost of doing that from a power perspective and from just a compute perspective. So we need novel architectures to deal with very low power embedded systems that can do things like machine learning, algorithms, always on. The second piece, when we think about video and doing understanding of what's happening in a video, I think Simon from Flickr made a point about this. This notion of not just labeling and tagging things, but we're seeing evidence of things like top-down attention control, where there's one field in machine learning, which is language understanding and language modeling, and there's another field in terms of image classification or object recognition. Combining those two together to be able to actually direct and say, this is the salient information, this is what's happening over time, versus just what's happening on a kind of a frame-by-frame basis.
Great. I feel Evan's presence behind me, all around me. I want to thank Carter and Samir for an excellent panel, and thank you guys for listening and asking great questions. Thanks.